Welcome back to Docs Off Topic. So today we're going to start tackling the next part of the project to get back gearing on my blue project lathe, and that is to gear up to drill out this for its spindle. This is the back gear. It's been sitting there cut and ready to go for almost the entirety of this year. And I figure it's time to make a start on the next bit. So what I'm going to do is make a boring bar that goes down the length. So follow along as I make this boring bar. Now I know you can't really see it all that clearly, but this one is through coolant, Indexable, and looks the goods. Let's get some material in the lathe and let's have some fun. Alright, I figured you guys weren't all that interested in watching me hog 1-inch bar down to 20mm for this boring bar. So I've done that off camera. We're going to start drilling the coolant through hole. Now it will ultimately be 8mm end to end, or near as I can. It'll be a 21 centimeter deep hole, which is not going to be a hell of a lot of fun. But we're going to start off at 6.5 because I've got an extended length which will get me about yay far, which is within 8 centimeters of full depth. And then when the drill that I've ordered for this project finally does arrive, I will finish this off. So this is going to take a little while, this project. Now when it comes time to actually do the full depth, I will set this up in the 4-jaw to reduce the stick out, because that drill is 300 long and I don't have the clearance. The lathe is just not big enough if I leave it where it is. Switch it out. those wondering, the steel is 4140 and it's semi-hardened. It's drill rod or sucker rod. Okay, what I'm going to do is I'm going to change out to a short version of the drill that will ultimately, which is 7.95 millimeters, and that will give me a little bit of clearance. Alright, so we're at 4.734 inches, which is, yeah, 119.5 millimeters, give or take a little bit. I'm just going to center spot this, just to bring that chamfer into a 60 degree. In case I need it. It's a brand new Osborne 11 millimeters, and I've forgotten I had these. Okay, so we have about 4 centimeters to go. I didn't bring you along for the bulk of this because this is the most tedious thing I've ever done. And I have to do it in the back gearing. And get it far down as I can. Because there'll always be a little bit of swath I've pushed ahead. So that's it, it's bottomed out. See? Now, 42 millimeters to go. Do it by about 5 to 8 millimeters at a go. Any more than that and I find it packs the flutes out a bit. And as you can see, this is an extended reach, not extended flute drill, which is annoying, but what are you going to do? Best I could get locally. Once I've got it pretty close to that line, take an accurate measurement and then we'll bring it to the exact depth required. So that's about it. This is the tedious bit. I have to use this as a kind of winch to pull the thing out. Quite a lot of vacuum in there. Nice away though. Gently, the rest away. Let's do this, we'll go that way. Let's go. Okay, let's measure that. Okay, so, because this doesn't need to be 100% accurate. Okay, 3 millimeters to go. Realistically, it would work at this point, but I would prefer it as per the design that I've come up with. Something I don't like doing in this lathe is parting. It's just not fun. I have nowhere to put stuff. I just need to get that lip off. That lip marks the actual length. Plus or minus a fraction of a millimeter is not going to make any difference. Okay. Nice chamfer. machine. Alright, so what I'm going to do is now that I've set 0, I'm going to go down 1 millimeter. Cut across, cut along, so more or less on center, until I get just past the 210 mark, because when I mill in this, any excess is going to disappear. Okay. There's going to be an element of regret to this. I say an element of regret because I have a feeling I'm going to get showered in hot shavings. I need that 2 millimeters to provide adequate threads in the tool holders to lock this in properly. Okay, that's that bit done. Unfortunately, we've had to make a change of plan. The high-speed steel just wasn't holding up. I think this stuff work hardens too much. And it's old, probably. Right, let's start with. Right now we're 0.3 of a millimetre over the halfway point. I need it just under half so that we don't load the edge with any pressure when we lock the insert in. That's your 9.5, it's good to check that edge. Noisy! Now, verify. Should be 9.5. Oh, the calipers, it's 9.5. Now I know that this little angle gauge isn't super accurate, and I do wish I had a proper protractor, but really I just need clearance. And 10 degrees should do that. Okay, so vice is done. This is as parallel to this edge, and I know that the edges on this is parallel and they're square because I did it myself. Face is a ground, as you would have seen in the previous video when I made this or modified this one. So now that we've got it clamped down using that flat surface as the register, I can bring my cutter head up. Coolant happening. napkins. So that's there. Need to finish these washers though. Now, need to set up the rotary table because we need to do the pocket. Alright, so this is tap drill size for the mounting hole. Stop right there because that is work hardening something a treat. So I'm going to quickly tap this, simply because that will allow me, when it's time to drill out to make the pocket, it allows me a way of fitting the insert and seeing if we've got adequate. Go a bit further. Now I haven't actually chamfered this, and I probably should have. Didn't think it was necessary, given that I was about to mill out the top, and I hadn't actually decided to do this until this morning. Bearing in mind this is a half thou or 0.4 thou indicator, to metric 0.01 resolution, which is about 0.4 of an inch, 0.4 of a thou. So the fact that we're getting less than one division, less than half of one division, is like 1/10,000th error. I think we're good to go. Okay, so the vise is mounted. It's true in this direction to within half a thou. This is level and parallel to this. This is level and parallel to this. This is parallel to this in both axes. So now, given that that is sitting at 1 degree, I'm going to go around to 30 degrees, and then we will mill that first side, and we'll use this side as our adjustment to allow it to fit and seat properly. Okay, so it's leveled again, tightened up all the fixing wear. There should be nothing in the way there. So now, release the box. We took the opportunity to re-zero the readout. It's within a degree. Yeah, good. No, that's actually the right angle. much am I missing that line by? Oh, solid millimetre. Okay. That explains a lot. I won't go any further than that because that's going to impinge on that line. So let's get that one down to depth, and that gives us somewhere to machine to. Alright, so we're at depth. That one out of the way. Now, I'm going to do this one. Now, in theory, if I move this way, I should get a 60-degree cut. Now, I am leaving myself plenty of meat to remove. So, let's give this a go. Could I have done it in one pass? Probably. But why risk tooling when you don't have to? About half a millimetre to go. Okay, so I think that's got the front edge done. Just going to see how it fits. It won't get far enough in yet, but that looks like it's going to work out nicely. Alright, let's go back to doing this one. We have about half a millimetre to take off. We'll do that very slowly with a couple of trial fits. I'm doing a test fit with the screw, so that it bottoms out. Oh, I think that is absolutely perfect. It seats perfectly. The pocket is good to go. Now we just need to, at a tangent like that, drill into our center channel. So as sketchy setups go, that is a ridiculous amount of overhang. Let's find the center of, so that I can set the mill up so that it just makes a little flat there. That is sort of in line with that. And we're going to be going in at 15 degrees, which should see us intersecting the channel nicely, hopefully without drill breakage. That would just be a little bit annoying. Alright, let's find the edge. Now that should clear that by 0.1 of a millimeter. Okay, this is pretty much the last little job. Let's see if we can do this without breaking a drill. Yes! I was hoping I only had like the tiniest little bit to drill through. And yeah, 0.5 millimeter. So that is ideal. I'm doing this test at the full stick out that I'll be needing for the upcoming project. See what happens when I take 20 thou. Well, that's where I'm leaving off. I've got a very, very professional looking boring bow out of this. It's the fourth I've made. So this one uses a high-speed steel insert. I'll put some photos up at the end anyway. And I made that when I made my gingery lathe, which was like 20 some years ago, 22 years ago. Along the way with that lathe, I've made a number of forged boring bars out of 01 tool steel. Never been entirely happy with them. They always chatter a bit and you can never get the geometry just right, and you're always juggling with them and trying to get them set just right. This one, pretty big holes. You need to start out with a 22mm drilled hole for this one, but there is no vibration, no nothing. Even at a 0.5mm depth of cut in steel. And the best part, the workpiece comes out cold, because I've got through coolant for this one, and I am really, really happy. And I know why I don't have through coolant in the smaller ones, but damn it, makes a difference. So that's where I'm leaving off. If you've enjoyed this little build, hit the like, feel free to subscribe and share this video. And yeah, get out to your shop, have some fun, push your envelope. The degree of precision required for this one pushed me a little bit. There's a couple of things I'd do differently, but nonetheless, it works and I am happy. So, I'll see you in the next one.